Okay, so now this is the amplitude part, right? Now this is the amplitude part and this is the phase part. So you see here these are basically two parts of the wave. One is this envelope. The envelope is moving with a particular velocity, and these component waves will move with a particular velocity. Now what will be the wave of this this envelope? You will get from the from this thing, amplitude part. How you get that? This is delta omega t minus delta kx, right? So you take it to 0, so x by t will be what? Delta omega by delta k. Now if you put limit delta omega tends to 0, you will get d omega by dk. This is called as vg, or the group velocity. Okay, and for the phase part you will have this thing, phase part, omega t minus kx is equal to 0 you put, so omega t minus kx is equal to 0, so that will be x by t is equal to omega by k, and omega by k is called as the phase velocity. Okay, so this is the thing. Okay, now now the thing comes that what is this in quantum mechanics I told a particle is represented by a wave packet. Okay, in quantum mechanics a particle is represented by a wave packet. Okay, now how this wave packet moves? The wave packet moves by a group velocity. So you can tell the a particle in quantum mechanics moves with the moves with moves with the group velocity. Okay, acha, now there are certain interesting things here, that is this phase velocity. Okay, phase velocity cannot be measured. Okay. Okay, now here, so here say from the light the light from the bulb, okay, the light from the bulb travels in space, okay, travels in space with the group velocity. Okay, the light from the bulb travels in space with the group velocity. Okay, so so therefore the energy which is associated with the wave, therefore the energy which is associated with the wave, energy which is associated with the wave is transferred by the wave velocity, is transferred by Vg, by the group velocity. Hence hence all physically measurable quantities, are transferred with Vg, okay. Are transferred with Vg. Now now phase velocity is not like that. Phase velocity, it cannot transfer any measurable quantity. Okay, so phase velocity is not very real thing actually. Phase velocity can be greater than velocity of light also. Group velocity is the real thing. So in group velocity it transfers all physically measurable quantities. Phase velocity doesn't transfer any physically measurable quantities. Okay, so this is the thing. So and another thing is that your real wave, okay, real wave here real wave is like actually wave packet. Real wave is like wave packet. That is, this is the thing only, that is in quantum mechanics a particle is represented by a wave packet. So quantum mechanics is the I mean the real world you are describing. Okay. Acha, now here this now let us do some calculations here. That is a group velocity is represented by a particle. Okay, so how will you prove that? So lambda is equal to h by p by de Broglie's, I'm writing the short form, de Broglie's hypothesis. Okay, so p will be equal to h by lambda. Okay, so how can you write this? P is equal to h by 2 pi by lambda by 2 pi. Okay, so this h by 2 pi is what? H cut, and this lambda was 2 pi by lambda. 2 pi by lambda will be what? K. So P will be equal to, so therefore P will be equal to h cut k. Right, P will be equal to h cut k. Achha, now here according to Einstein's energy conversion formula, E will be equal to mc square. Okay, E will be equal to mc square. Now E is also equal to h nu for photon. E is also equal to h nu. Now how you can write this? H into h by 2 pi into 2 pi into nu. Okay, so this will be what? H by 2 pi is h cut and 2 pi nu is omega. So E is equal to h cut omega. So therefore from here what you can write? Omega will be equal to mc square by h cut. Omega will be equal to mc square by h cut. Now u is equal to phase velocity formula, u is equal to omega by k. Okay, u is equal to omega by k. So from here what you can write? Omega is mc square by h cut, and k will be what? P by h cut. K will be p by h cut. So this will be mc square by p. Now mc square by p is what? P is the momentum, so mv. So u will be equal to c square by v. Okay, u will be equal to c square by v. Therefore u will be equal to c square by v. Let me write here, u is equal to c square by v. Okay. Achha, now velocity of the particle. Velocity of the particle v will be equal to p by m. Okay, so this will be pc square by mc square. So this will be equal to pc square by e. Okay. Achha, now here from here this p is equal to h cut k. P is equal to h cut k. So dp will be equal to h cut dk, and E is equal to h cut omega. So dE will be equal to h cut d omega. Okay, so now here this, therefore from here dE by dP, dE by dP will be what? D omega by dk. So d omega by dk is what? Vg, group velocity. Okay. D omega by dk is Vg. Okay. Now dE by dP. Okay, dE by dP. Achha. Now here the total energy is how is the total energy given? Relativistic energy. The relativistic energy, the relativistic energy of a particle, okay, moving with velocity v almost equal to that of c. How is it given? E is equal to square root of p square c square plus m naught square c to the power 4. Okay, I had done it in the just before Compton effect. I had done it. Here E is equal, for relativistic particle V is almost equal to C. E is equal to square root of p square plus m naught square c to the power 4. Again I am doing some mistake. M naught c square, not m naught c square. This is here. This is E is equal to square root of p square c square plus m naught c square. Okay. Oh no, I was right only. E is equal to, sorry, E is equal to square root of p square c square plus m naught square c to the power 4. This is the energy. So E square will be what? E square will be p square c square plus m naught square c to the power 4. Okay. So now if you do the derivation with respect to, say, if you do the derivation here with respect to p, say, so 2e dE will be equal to 2p dP into c square, right? So 2 cancels, so dE by dP will be equal to pc square by E. Now E is what? mc square, so pc square by mc square. So p, this is p by m. P by m is what? V, right? D by dt is equal to v. V is what? V is actually the velocity of the particle. Velocity of the particle. V is the velocity of the particle. Now here what you have got? D by dp is equal to vg, and here what you have got? D by dp is equal to v. So from here what happens? What comes? That vg is equal to v. So this proves that group velocity is equal to velocity of the particle. This proves that group velocity is equal to velocity of the particle. Okay, again you see here d by dp is equal to vg, and from here we have got E is equal to square root of p square c square m naught square c to the power 4. Okay. So here from here dE by dP, we have differentiated it. 2E dE is equal to 2P dP c square m naught square c to the power 4. If you differentiate, nothing will come because c is constant, m naught is constant, so no differentiation. So from here d by dp is equal to pc square by E. Now pc square is pc square and E is mc square. So p by m, that is mv by m. So v is actually the velocity of the particle. So from here vg becomes equal to v. So from here group velocity is equal to velocity of the particle. So this proves that, this only proves that the wave packet. Now vg is what? Vg is equal to the velocity of the wave packet. Okay, did I write here? Particle is represented by the wave packet. Particle is represented by a wave packet, Ajay. So here I will write here Ajay. So this proves that the wave packet moves with the wave packet moves with the group velocity. Wave packet moves with the velocity of the wave packet is called as the group velocity. The wave packet moves with the group velocity. Okay, Now, if you are asked some question that what is group velocity, what is phase velocity, you will write that the velocity with which the wave packet moves forward in the medium is called as the group velocity. The velocity with which the wave packet velocity with which the wave packet moves forward in the medium is called as group velocity, and the velocity of the component waves within a wave packet is called the phase velocity. Which is denoted as u. Okay, which is denoted as u. So this is the thing. And another thing that in the Compton effect, I had done in the last class, that is Compton effect. Before the Compton effect class, here actually this E I had written right only. This will be E is equal to square root of P square C square plus M naught square C to the power 4. Okay, I had first written M naught square C to the power 4, then I had cut it and write M naught C square, but that is not right. Okay, you write this, if you have written that, you cut it and write this one. E is equal to actually square root of P square C square plus M naught square C to the power 4. Okay, and in this case, if here I had shown that only two waves are superposing. Now if there are infinite number of waves, superposing, what will happen? The wave packet will become basically like this, a delta function, like this. It will become a delta function for superposition of infinite number of waves. Okay, and in quantum mechanics, what do you tell? I told that I mean the position or the the future of the year can never be predicted. You can never predict the position. You can, in quantum mechanics, you can always tell that in terms of probability, that the it can lie within -5 to +5 centimeter, or it has momentum in between -20 to 50 kg meter per second, like that. So here what do you told? Here it has been reconciled, that is wave and particle characteristics have been reconciled. That is, this thing, this entire wave packet is, you can consider it as a particle. And you see here, here it will have particle as well as wave nature only, because here these are the component waves, means the particle, here what will happen is that here the probability of finding the particle is more, here it is less. Actually it is like this, like this kind of thing, means say like this. This is actually a wave packet. Okay, now here at this region, this region the probability of finding the particle is the maximum. Here it is minimum. Okay, and in other regions the probability is 0. Okay, so in this region the probability of finding the particle is maximum, and other regions it is minimum. Okay, so so within this wave packet, okay, so here you see that it is behaving as a wave as well as a particle. Okay, so this entire thing is behaving as a wave. It is moving forward in the medium, and within this wave packet you can find the particle at any point. Okay, at any point you can find the particle. So that is why here it is reconciled, that is wave and particle nature are reconciled. Okay, so this is the thing. Then comes your this d by dp is equal to v. Okay, so here you had got this thing, u is equal to c square by v. U is equal to c square by v. You have to find out that relation. Now v is what? The velocity of the particle. Now from here you have seen that v is equal to vg. Okay, that is group velocity. So instead of v you can put here vg. So what will you get? U into vg is equal to c square. U into vg is equal to c square. So from here this is the relation between group velocity. This is the relation between group velocity and phase velocity. This is the relation between group velocity and phase velocity. U into vg is equal to c square. This is the relation between group velocity and phase velocity. Another interesting thing is that you see here u is equal to c square by v. Now v is the particle velocity. Now since v is particle velocity is always less than c. Okay, like according to the special theory of relativity, no material particle can move with a velocity greater than that of light. Okay, since v is always less than c, therefore c u is greater than c. That is, phase velocity is greater than the velocity of light. Phase velocity is greater than the velocity of light. You see, this is such an important important, what to say, derivation here, that u is equal to c square by v. It is so so interesting that phase velocity is greater than the velocity of light. Isn't it very sounding very crazy kind of thing? But it does not. According to a special theory of relativity, no material particle can have velocity greater than that of light. So it must. So this phase velocity is greater than velocity of light. This can contradict STR, but no, it does not. It does not contradict. It does not contradict the special. Does not contradict the special theory of relativity. Does not contradict the special theory of relativity, since phase velocity since the phase velocity or the phase waves phase velocity or the phase waves, which are the phase waves? Now these component waves, these are the phase waves, and these component waves, these phase waves does not carry energy. Since the phase waves does not carry energy. Okay, I have written it earlier also, that is, see here, the light of the bulb travels in space with the group velocity. The energy which is associated with the wave is transferred by Vg. Hence all physically measurable quantities are transferred with Vg. Okay, u does not u does not u is phase velocity, does not uh, uh, transfer does not transfer physically measurable quantities, does not transfer physically measurable quantities. U does not transfer physically measurable quantities. So that is why you see here u is greater than c, but it does not contradict the special theory of relativity, since phase velocity does not carry energy. Okay, so this is the thing. Thank you for this lecture.